Hello, Mr. Geiselart here, and this is a fairly complicated looking question. It looks like we have powers to powers, we have exponents, we have negative exponents, we have fraction. So let's try and do this one step at a time. The first thing I'm going to want to do is I'm going to want to get rid of this exponent up here by distributing. Remember, when you do a power to a power, you multiply. So I'm going to rewrite this whole thing so that it will look something like this: x to the 7th times y to the 8th times z to the negative 4th. So all I did is I multiplied that exponent there and those two exponents there over x to the negative 8th, y to the negative 3rd, and z to the negative 6th. Now, I have these parentheses here because they were there, so I just wanted to keep them there and show them there. However, they really don't mean anything different than if they were gone, because all I'm doing is multiplying these together. So what I'm going to do now is use the quotient rule with each one of these variables to try and come up with the answer. So it'll look something like this. Now, I'm going to start off with my x's. I have x to the 7th minus a negative 8. So when you add the opposite, that will give you x to the 15th. For my y's, I have y to the 8th minus a negative 3. So you add the opposite, and that will give you y to the 11th. For z, I have z to the negative 4th minus a negative 6. Negative 4 plus 6 is going to be 2, so that will be z squared. So now what I do, if it's a positive exponent, that just goes on top. So I have x to the 15th, y to the 11th, z to the 2nd. Now, if everything cancels out, whether it's on top or bottom, it would be over 1. Now, we usually don't write over 1 because anything can be expressed as a fraction over 1, and if it's over 1, we usually don't write it as a fraction. So my final answer would be x to the 15th, y to the 11th, and z squared.